Welcome to Ask and Learn.
So they want us to determine whether these three Hasse diagrams are lattices or not. So remember, to be a lattice, we want to show that we can choose any two elements of these sets, and we'll have a greatest upper bound and a least upper bound. So actually, let me go ahead and move these down here because we'll need a little bit of room for this. So if it is, we have to show that every single one of these has a least upper bound and a greatest lower bound. So let's go ahead and just start. So what about lowest upper bound of GF? Well, the upper bound for these would be G, and that would be the smallest, so that's just G, so that looks good. Now, what about the lowest upper bound of D and G? Well, that's also G. So you can first notice that everything we would have for the lowest upper bound of any of these elements, X with G is going to be G. So it doesn't look like we really need to check that. So that top one is good for upper bounds. All right, now what about this next one? So the lowest upper bound of F and D. Okay, well, what is this? Well, this is going to be F for the least upper bound, because notice that we could also have an upper bound in G, since remember this is going to be oriented in this direction due to the Hasse diagram having the greater elements on top and the least elements on the bottom. And then if we were to do like, I don't know, F and E, so lowest upper bound for F and E, well, look, that's also going to be F. All right, and so then it looks like everything with F would have that same thing where the least upper bound for this is going to be, so X with F is just F, as long as X is in G, but we've already shown that over there. All right, so we did both of these. Now what about D over here? Well, let's do lowest upper bound of D. Well, we could do that with E. Well, for these, well, we have an upper bound in F and G, but the lowest of those would be F. Okay, now what about lowest upper bound with D and B? Well, since D is above B, that means it would just be D. All right, now what about L, or so least upper bound of D and C? Okay, so let's see. So our upper bound is F there, and then C is also in F, so that's just going to be F. All right, so that looks like it's good. What about A? Well, with A, that's just going to be D since A feeds into D. So AD is going to be D. Okay. Now you might notice we're going to run into this same kind of pattern for these. So if, so because I really don't want to have to write the rest of these out. So the thing we are going to notice is that these will all have a least upper bound, since if you have something where it's on the same line like this, then whatever element is above it, or whatever the top element is, will be that least upper bound. Same thing over here. Okay. Now, if you had something where it's like on these diagonals here, you first just go over to the right like this, and then this will be the least upper bound, because then that one just feeds in it like that. So we really don't need to check the rest of them for the least upper bound, but that's the kind of the process you would go through. All right, so now hopefully we don't need to draw these out, and we can think of a similar process for those. All right, well, we'll do a couple by hand first though. So we want the greatest lower bound. So let's do G and F just for practice. All right, well, G and F, well, the lower bound here, since F is below G, would just be F. Okay. Now what about G and D? Well, the greatest lower bound of G and D, well, that looks like it's also going to be D. So then, I don't know, let's do greatest lower bound of G and E. Well, that's also going to be E. And you can kind of see, since G is our maximal element, if we just choose one other point, that's going to have the other point as our greatest lower bound. So it'll just kind of keep on going down like that. All right, so let's try something more interesting. Well, what about F here? Well, so the greatest lower bound of F, well, if we do that with D, that's just going to be D. The greatest lower bound with E, that's just going to be E. And similar to G, all the ones below this one, since everything feeds into that, will just be whatever that point is. So all those have greatest lower bounds. All right, now what about D and E? So let's check this out, because that is going to be a little bit more interesting, it seems. So D and E. Well, here we have that. So now we're wanting to feed downwards between these two. So we're working backwards. Well, both of those feed into B. So the greatest lower bound for that is going to be B. Now if we do like D and C, well, C feeds into A and then D feeds into A. So the greatest lower bound of D and C is A. And so you can see that first, if kind of for similar reasons, if we have something that's in the same column as it, then it's just going to be whatever the lowest one of that is. But if they're off on diagonals, so here you just go down the diagonal like that, and eventually you'll hit something, or you go across the diagonal and then go all the way down. So it looks like all these also have a greatest lower bound as well. So you could go ahead and keep writing all those out, but the same idea will apply for these. So yes, this is a lattice. All right. Now, what about these two? Well, notice that B and C, I don't believe have a greatest upper bound. So let's see. So let's just find upper bounds first of B, C. All right, so, well, it looks like G is an upper bound for this. So G. We also have F being an upper bound for these. And we also have H being an upper bound for these. Okay, but now for our least upper bound of BC. All right, well, so we're looking for which one is smaller than these. So first we could just go ahead and get rid of H, since H is our maximal element. So now it's really between F and G. So for this to be the least upper bound, we would need either F to be less than or equal to G, or G to be less than or equal to F. But if we look at our diagram here, so let me go ahead and scribble these black again. If we look at this diagram, you might notice that there is no relationship between G and F. So this is not a lattice, and the reasoning would just be over here. So we would need either F less than or equal to G or G less than or equal to F, but F, but neither are true. All right, so that's unfortunate. All right, now let's go to this next one here. All right, so we need to go through that same process, checking to see if greatest lower bound, greatest lower bound, and least upper bound. All right, so again, kind of going based off what we did for that first one, notice that I, if we do the least upper bound of anything with I, this is just going to be I. So that's okay. And then if we do the least upper bound of anything with H, this is going to be H as long as X is not I. All right. Now let's see if we can do these other ones. So for F and G, well, both of these feed into H, so that would be its least upper bound. Well, what about D? Well, that just follows to F if it's F and D. If it's F and B, so notice again for similar reasons, if it's on this same column, then it's just going to be whatever is up top. And same thing over here. If we have anything like that, it'll just be whatever is up top. All right, and then you can check some of the other ones as well, but you will end up seeing that all have a least upper bound. And now let's use similar logic for the greatest lower bound. So if we were to, so let's start again. So if it was I or H for similar reasons, those are just going to be whatever one is below it. So we really don't need to check those. So let's just start with like F and G and C. Well, we can follow this back to B here, and then this follows it to B. So it looks like that works. So anything in this column here with G is going to have the least upper bound of B. So we don't need to check any of those with G. Now what about E? Well, E and F are going to have the least upper bound of A, and similarly, anything in this column here is going to have that least upper bound of A. So seems like everything has a least upper bound and a greatest upper bound, and you can just you could write them all out if you want, or you can just kind of use this rationale here. So all have greatest lower bounds, so that means this is indeed a lattice.